You're listening to the Effective Statistician podcast, the weekly podcast with Alexander Schacht and Benjamin Pieskett, designed to help you reach your potential, lead great science, and serve patients while having a great work-life balance. Today I'm talking with one of my team members about her PhD thesis, which is about prediction modeling. So stay tuned for an awesome discussion with Chantelle. Have you already heard about the Effective Statistician conference that happens in November of 2024? So it is just a little bit less than 2 months away. And what is just a week away, if you're listening this to at the day when it actually goes live, is our increase in the prices for the premium access to the conference. The premium access includes all recordings and especially all the different workshops. And we have an increasing number of different workshops. I think each of them is actually would be, typical for price of the conference overall. And you can, of course, get into many of them. So, for example, we have Daniel Sabanis, who is a statistical software engineer, and he will talk exactly about this. We have a group of statisticians from Bayer and PI who will talk about machine learning. We have Darko with simulated and synthetic data generation. And we have also something for you specifically to boost your personal productivity. Taina will speak about how you can use Notion for that. And Peter will talk more about effective self-management from his background of being a psychiatrist. So there's much more on that. Check out the homepage and sign up for the premium version of the conference to get all the content, not just the free one. So stay tuned for that. Just check out my homepage, theeffectivestatistician.com, and there you will easily find the link to the conference page. I'm producing this podcast in association with PSI, a community dedicated to leading and promoting the use of statistics within the healthcare industry for the benefit of patients. Join PSI today to further develop your statistical capabilities with access to the video-on-demand content library, free registration to all PSI webinars, and much, much more. Head over to the PSI website at psiweb.org to learn more about all the upcoming PSI activities and become a PSI member today. Welcome to another episode of The Effective Statistician. Today it's awesome to have Chantelle back on the podcast. So last time we talked about the conference, and if you haven't listened to this episode, scroll back. Today we will talk about a more technical topic, and that is predictive modeling. Now, that appears to me to be a pretty broad term, Chantelle.
Yes, you're very right, Alexander.
What is it actually?
So predictive modeling is a very general term for any statistical technique that can be used to forecast future outcomes based on historical data. And it involves creating a mathematical model that can predict future events or behaviors by analyzing the patterns in the data.
Yeah. So what are typical use cases for such predictive modeling?
Well, it spans a load of industries, not just healthcare, but myself in particular, I'm interested in survival modeling. And what this typically involves is estimating or predicting one's chance of survival. And that could mean time until death or time until an event. But other uses of modeling could be to estimate someone's response to a treatment, for example. There are so many.
So in terms of these models, do I need to think about it like, okay, if there's this model built, I can basically put in data for a specific patient, like myself, or kind of, someone that, is of interest to me, or, the physician can put then these in, and then I get some kind of probability, things like that out of it.
So that's a very good question. The answer is no.
Okay.
Every predictive model is made with a specific population in mind. If I were to create a predictive model for people living in the UK, for example, that's where I am, and it was a model estimating how someone would react to a treatment based on physiology and a bunch of other factors. If I took that same model but predicted people from, I don't know, China, for example, you wouldn't expect, or maybe you could, I'm not the expert here on the treatment. You wouldn't expect the people from China or India, for example, to react the same way. So you'd need another model.
Yeah. So it's really important to kind of think about, are you extrapolating here or interpolating in terms of the model? So if you think about all the data that the model was trained on, the data that it should predict should kind of be in a way similar to the data it was trained on.
Yeah, this is really important. So we have a way of developing prediction models, and the typical split is you take your data set that you're developing the model for, and you'd say, okay, I'm going to use 50% of this data to train the model. And then you'd set aside a further 20 or 30% to test the model. And this is completely independent of the data you trained it on. And then you have another 20 to 30%, obviously has to add to 100 to validate your model on. But all of these would come from the same cohort.
Okay, so let's go through these 3 steps. So training a model, what does that mean actually?
Okay, so we can describe a prediction model like a white box. We have a bunch of inputs. So say if I wanted to make ice cream, I'd have my milk, sugar, flavorings, and not organic ice cream. And you'd put these into the box. And the box is this method, this prediction model, or the ice cream machine, and then your output would be the ice cream. So the way you'd go about developing this model is you typically do some exploratory analysis. And this is looking at the data you have and figuring out, okay, can I see any patterns in the data? You'd look at your outcome and check how it relates to each of these inputs. Maybe there is a linear pattern, and this would typically show a linear model is the most appropriate. There are loads of other relationships that these variables can have with the outcome, logistic, for example. And we would look at the data, check for outliers, maybe do some imputation for missing data if that's appropriate. And it's an iterative process from there. So you'd use your software, and using the software, you'd then choose which of these variables or characteristics of your data are most appropriate for predicting your outcome. And you could try different models, for example, in survival. There's quite a few of them, notably the viable model and the Cox, that can be interchangeable based on assumptions. And also, I should have said previously, in your exploratory analysis, check any assumptions for models you may want to do, check that they hold, because otherwise the model that you end up with won't be much use if they don't.
Cool. Yeah. So the training part is basically to set up this model, so that you have all the parameters, or the model itself, kind of what kind of mathematical function you have, what kind of error distribution, all these kind of different things. That's the training part. Okay,
it will be a working draft.
Okay.
So I guess that takes us to the next bit, which is the testing. And for me, testing is a bit of an iterative process. Again, I wouldn't use the testing data to then go and redo my model. But say if the metrics for my tests come back and say, oh, this model is actually pretty rubbish at predicting our test set of patients, then I would go back and go, okay, maybe I need to try another kind of model. Maybe one of my assumptions didn't really match, or maybe I've missed a huge variable that was actually very much a key variable for predicting that outcome. Then you'd go back and forth. Creating predictive models, particularly ones that are useful, is a very long process, and it's something that definitely should not be rushed.
Okay, so in terms of, so I have now my model, that I got from the test cases. And now I put the input data into this model and get out the predictions. And of course, I have the actual cases. So I know what is reality and I know what was predicted. And now I can look into how much that aligns to each other. So for example, I can look at the predicted survival curve and the other curve, and kind of can look at the correlation of these. So I think the really important thing is that you look at the correlation and not so much or coincidence, and not so much whether you get the same picture, because, well, it's for the individual patients that you want to make a prediction, not for the population, isn't it?
Yes. So typically you'd use metrics such as calibration or discrimination. This is just for survival modeling. If anyone's not guessed yet, that's my thing. It's what gets me out of bed in the morning. And you'd typically, as you said, you would take your predictions, like your Kaplan-Meier curve, and plot it next to the actual Kaplan-Meier curve. And obviously there's room for a bit of error. No prediction model is perfect. But you want to make sure that it's not useless. You want to make sure that if someone is incredibly sick, you've tried every treatment, that it's not going to predict that they're going to be perfectly healthy tomorrow. Right?
So putting both Kaplan-Meier plots on top of each other. So you would get, from a prediction of survival, you get kind of a time to event. Would you get also the probability of getting censored in that case?
No.
Okay.
Not specifically. I need to check on that one.
Okay. So that's really interesting. And of course, then looking into, okay, do the patients that are, at the start of the Kaplan-Meier curve the same on the predicted than on the actual ones that So that's super interesting. Would you? So one other question I have is dividing the test and the training data set. Do you do that at random, or how do you select?
Yep, typically at random. There's a bunch of different methods we can use. So I typically just use a built-in R package to randomize the split. Some people will do, okay, so starting at the first, second, or third observation in the data set, I want every fifth one, and then pull those together, and then the next load would go into the second. There's a lot of different randomized sampling methods that people use, but you want to make sure that it's randomized, particularly if there's some order to the data that you're using.
Yeah, completely agree. What you mentioned the word calibration. What does calibration mean? Can you explain that without a formula?
Yes, it's typically the alignment of what we expect versus what actually happens. So typically you would have a curve, and you'd want that curve to be a straight line.
Okay. That is, you basically look for each patient in terms of the predicted versus the actual value, and if that is on a straight 45 degrees line, then it's perfect. Okay. Yeah. That is kind of as if you would have binary and you have perfect concurrence. Yeah, that's
exactly.
Yeah. Cool. What other characteristics would you look for a good prediction model in this test case still?
So I like to say that the simpler the model, the better. So you can have a model with 30 plus variables in it. And in most cases, that's going to perform quite well because the more information you have, the better. But the issue with those models is interpretability. Mm-hmm. A model is completely useless if the clinician can't interpret the result and doesn't understand what the model is doing. So as statisticians, we have a responsibility to ensure that our methods will be used to benefit the patient. So I like to make sure that my models are as simplistic while also taking into account as much information as is useful. We don't want to add variables for the sake of just increasing the prediction a tiny amount, because that leads to a lot of issues further on.
Yeah, so there's a couple of considerations in there. Collecting data is, by the way, not free. Yeah, so the more data you need into the model, the more it becomes actually expensive to run it. And also there's this very high likelihood that, as you said, some variables will not add a lot of meaningfulness. So how do you prune a model so that you kind of have only those variables in it that really contribute a lot?
Yeah, so I'll answer your question in just 2 seconds. One thing I want to emphasize with the whole more data element is that for prediction models, there was a really great paper by Richard Riley et al. For sample size criteria for prediction modeling that said that as a rule of thumb, you don't want to have more, you need to have more than 10 observations per variable you add in the model, and that's events. So taking them aside, obviously, if you have 20 people in your data set, you wouldn't want to have more than 1 or 2 variables. 20 would be a rubbish number. I would freak out life fast to make a predictive modeling based on 20 people. Yeah. Going back to your question about sort of feature selection, choosing the variables, if you had your variables and it wasn't clear based on p-values, for example, which ones would be better than others, and you had loads, one method, and sometimes people refer to it as overkill, I think they can be useful in certain circumstances, and it's something I'm working on at the moment actually, is penalization techniques. And these are a mathematical tool that sort of makes sure that the model is as sparse as can be. There are different versions, for example, lasso, ridge, and horseshoe penalization, and they look at each of the scale of the coefficients for each of these covariates and try and shrink it as much as possible if the variable isn't as useful. So I'm looking at it at the moment in the context of multi-state modeling. There's been a great paper for clinical prediction models by Richard Riley and Glenn Martin on penalization techniques in small sample size sort of environments, and it's a great read. But yeah, you typically use feature selection techniques, including penalization, or there are simpler methods such as step regression, where it adds one variable at a time to a model. Yeah. And goes, okay, does it add any more value? And then you could reverse it, see how much they align. But typically, you'd have some background information from prior research to building the model that would tell you, okay, maybe this variable is more useful than others. So I'd strongly suggest using the reasoning approach before going for anything more technical, especially if you don't fully understand the methods.
Yeah. Completely agree. Really understand all the different variables in it. I have early in my career done that, and I didn't completely understand it.
We've all been there.
That one of the variables was just the log transformation of another variable. Yeah, and so you definitely want to avoid kind of having both the original and the log transformation in it, usually. So now we have the training and the test, and now we get to the validation. When do we make that step from test to validation?
So I would recommend doing it once you've done this iterative process of, okay, test, train, and you are happy with your model. And this validation is a last final check, just to make sure you haven't done anything radically wrong before saying, okay, this model is useful and can go into practice.
Yeah, cool. So what we just talked about, lots of traditional methods. Yeah. So if you look into some of the classical, now they would be called data science books, like Elements of Statistical Learning, you can probably find lots of these things in there. Now there's this big hype about artificial intelligence. Will that take over completely from these traditional methods?
So I might be echoing Casper from the hype episode of this podcast. I don't have a straight answer for you. Probably not. But AI methods can also be quite useful. So the way I like to think of this is, as statisticians, we have a toolbox. If we were electricians, every electrician would take the right tool for the job. You wouldn't take a spanner when a screwdriver would be needed, for example.
Yeah.
So we have a responsibility to educate ourselves and pick the right tool. So there are many differences between statistical versus machine learning AI, and just one of them would be interpretability.
Yeah.
If I needed my model to be interpretable, I wouldn't go for AI and ML. I would go for standard statistical methods. And if one thing that machine learning techniques can do very well is in small sample sizes, and we know that standard statistical techniques aren't great at that. So it's really about picking the right tool and keeping up to date with the methods. And that can be quite difficult, especially now that it seems every other day there's a new AI method. And it's really spiraling at quite an impressive rate. But yeah, just to echo myself a bit, you do need to make sure that you are educating yourself and that you're picking the right tool at the right time to do the right job.
Yeah. Absolutely love that. Yeah. So it's definitely an area to explore. It's definitely an area to learn about and to work together with people that come from that space. Yeah. I think the biggest advantage we can get if we work together, learn from each other, embrace the opportunity, and do the best with it. And I also love the episode with Casper. That was super fun. So the Casper Rufibach episode got published some time ago. Just scroll back a little bit in your podcast player and then you will find it. Now, one last question. If I want to do all of these things, what type of tools do I actually use?
So clinical prediction modeling?
Yeah.
It depends on what you're most confident using. The toolbox analogy. So for me personally, that would be either R or Python. I have some experience with SAS, but you really just need to make sure that you are using a tool that you're comfortable with and you know how to use. Yeah. So, yeah.
And I've definitely used...
It's a very general answer.
I definitely used SAS for a couple of these things. Yeah. There's lots of built-in things within whatever, Proclogistic or other things. Yeah, whatever you want. And so have a look into what's possible there. Yeah, and of course, if you're really into programming and you're multilingual, that always helps. Yeah. So speaking about this, if you really love SAS, we also have a SAS to R course that helps you to learn more R, and that is specifically designed for people working in clinical trials and health data, these kind of things. And it comes with an awesome presenter called Thomas Nightman, who has helped lots of people that are statisticians, programmers, and knows us in the pharma zero space and transition to R. It's a really, really nice course. It's also both pre-recorded and interactive. So just check out the Academy on the Effective Statistician for that one. And when the next live training will be, you can always look into the recordings. Thanks so much, Chantelle, for this awesome discussion about predictive modeling. We talked about a couple of different use cases. We talked about testing, training, validating, and went into quite detail about kind of pruning and all these kind of different things. I think it's an absolutely fascinating area, and it is definitely something you can explore and have a look into. There's a lot of applications within healthcare around this.
Thank you for having me, Alexander. It's been a pleasure talking about something that I could talk about for hours.
Yeah, that's kind of the nerdy part of this podcast. I love it. Don't forget to sign up for the conference and make sure you secure the premium spot that gives you access to all the different workshops. This show was created in association with PSI. Thanks to Rain and her team at VVS who helped with the show in the background, and thank you for listening. Reach your potential, lead great science, and serve patients. Just be an effective statistician.